So problem 56, one more example with intersections. We have to first solve each inequality, and then we'll take a look at the graphs and see what it says about our solution. We're looking for where these graphs overlap. And we know that because we have an and here. So we want to see what's in both sets simultaneously. Now to solve here, x is being divided by 4 and multiplied by that negative. So I'm going to try and take care of both of those things at once. To get rid of everything on the left-hand side except the x, I can multiply both sides by negative 4. So let's do that. Multiply by negative 4 here and negative 4 here. Now when I multiply by negative 4, what special thing is going to happen to my inequality? Yeah, it reverses direction. Because when you multiply or divide both sides of an inequality by a negative, it changes the direction of the sign. So on the right-hand side, I get 10. On the left-hand side, that cancels and the negative cancels, so I get x is less than 10. Okay, not so bad. Let's try the other one. For the other inequality, I'll distribute the 2 and get 8x plus 10. And solving this one's going to be a little bit more friendly. I'll subtract 8x from both sides and get x is greater than 10. So let's graph these and see what that looks like when I graph them. So we'll draw ourselves a number line. There's really only one number that I need to put on it, and that'd be the number 10. And then I want to graph both of these. So I'll use green for this one. And I'll use orange for this one. Hopefully that shows up okay. So x is less than 10. The way I could draw that be a hollow dot. How come I'm putting a hollow dot on that 10? Yeah, you're not including the 10. You're not including it because it's a less than, not a less than or equal to. Which way is the arrow going to run? To the left or to the right? To the left. So arrow to the left. It's going to look like that. By contrast, x is greater than 10. It's going to be another circle. This time, which way is the arrow going to run? To the right. Now what you need to think about carefully is where these overlap. Where do they cross each other? Where do they intersect? Go ahead, it's on your lips. They don't. They don't. So this and this has an intersection of the null set. That is, there is no intersection. So no solution, no intersection, null set, empty set, however you want to say it. Now, if we were to turn this around, if we're looking for the union, if I was looking for x less than 10 union x greater than 10, then it'd be everything would be in the union except 10. 10 would not be in the union. So it's all real numbers except the number 10. And that's actually a little bit of a lead into the next part of this. Union is going to be a little bit more challenging to deal with, but we'll see. Let's take a look at a couple problems involving union. We'll move along with problem number 78. So for 78, we've got x plus 2 is less than or equal to 10. Or x minus 3 is greater than 2. Greater than or equal to 2. So solving these is not going to be a tremendous challenge. For the first one, I'll subtract 2 from both sides and get x is less than or equal to 8. For the second one, I'll add 3 to both sides and get x is greater than or equal to 5. As before, I'm going to draw these with different markers. Let's take a look at the graphs of these and see where they overlap. As far as your graph is concerned, I really only need to see two numbers, 5 and 8. X is less than or equal to 8. What's the graph of x is less than or equal to 8 going to look like? Solid dot. Good, thank you. Solid dot. Which way is the arrow going to run? To the left. Good. And then solid dot again for x is greater than or equal to 5. This time the arrow is going to run to the right. Oops. Now you got to back off your mindset from intersection. The intersection would be between 5 and 8, but that's not what we want. We want to look at what's in either set. How would you describe what happens when we put both sets together? What do I get? If I combine it, if you're in one or the other, then you're in the union of these. So what's the combination of both of these? Got one lonely voice here helping us out. Go ahead. Yeah, everything. Negative infinity to infinity. You're in one set or the other set or both. But either way, every number on this line is covered by either the green line or the orange line or both. So negative infinity to infinity, or quite simply all real numbers. Let's try another one kind of like that, and it's going to be a little bit of a review of some stuff we did the other day in terms of working with fractions and decimals. By the way, there's a part B to this. Part B is to ask for the intersection. The intersection of those two would be just where they overlap, and the intersection would be 5 to 8. So it'd be that little interval. That's your part B here. Okay, as promised, let's move on to problem 62. So we've got y plus 0.52 is less than 1.05y, or 9.8 minus 15y is greater than negative 15.7. Okay, so let's look at the union of these two things and see what we can come up with. Now for the first one, it's kind of up to you how you want to solve this. I can see doing this in a lot of different ways, but one thing that I want to practice with you is clearing out the decimals if you need to. So this problem probably looks pretty ugly because it has these extra decimals. What can I do to get rid of the decimals? Yeah, multiply by 100. So I'll just put 100 outside here. Each term gets multiplied by 100. So when I multiply everything by 100, what would I get? 100y plus 52 is less than 105y. Good. So that's nice. We cleared out all the decimals. Now, kind of following along Jeff's rule, since this is the term with a bigger coefficient, I'm going to move the y's to the right-hand side. That means subtracting 100y from both sides. So I get 52 is less than 5y. To finish things up, I'll divide both sides by 5. I think that gives you 10.4 if you want to write it as a decimal. One thing that's kind of convenient, if you were to write this with the variable on the left-hand side, then it's a little easier to graph. Let me show you why. Let's write this with the y here and the 52 over 5 here. What inequality is going to be between these if I flip it? Less than or greater than? Greater than. Keep in mind, the alligator eats the bigger number, right? So the bigger number here is y, bigger number here is y. So what's more convenient about this? Well, when the variable's on the left-hand side, it points in the direction of your inequality, which way you're going to graph it. So we're going to graph this to the right. So it's nice. Let's take a look at the other part of this. What do I need to multiply this one by? Yeah, 10 would be good enough. Anything more than 10 is going to be overkill. So multiplying by 10, I get 98 minus 150y is greater than negative 157. So subtract 98 from both sides. Negative 150y is greater than negative 245. 245. Someone want to double check me on that one? 255. Thank you. Then divide both sides by negative 150. What happens when I divide by negative 150? Yeah, you have to flip the direction in inequality. So y is less than some number. I'm sure that's going to reduce because 5 goes into both of those. So it'd be, what, 51 over 30. Let me remind you, if you have a fancy graphing calculator, that can help you. If you do 255 divided by 150, oh, even better, 1.7. So 1.7. I was going to say, let me finish this up though. If you hit the math key, then answer the fraction, it'll put it in lowest terms here for you. So 17 over 10 would be a nice fraction in lowest terms. So let's graph these. Remember, there's an or between these. So I want one or the other. 52 over 5 is out here. 1.7 or 17 over 10 is here. So x is greater than 52 over 5, arrow to the right. And y is greater than 52 over 5, or y is less than 1.7, arrow to the left. Now we're looking for the union of both of these. So it's one or the other. And there's not much I can do to simplify it. It's just going to leave it like this. You've got the interval note, or excuse me, the inequality here. You've got the graph here. And then the interval notation would be this. Let's take a look at this interval. What's the left-hand endpoint of this interval? Negative infinity to 1.7. Bracket or parenthesis around the 1.7? Parenthesis. Union. Parenthesis 52 over 5 to what? Good. Positive infinity. So there you've got all three different forms of your answer. Now typically I'm only going to ask for one of these when I test you on this stuff. But you should be comfortable with the equivalence between all three. How are we looking on problem 62? Yeah, please. It's a great question. If this was a greater than or equal to, then I'd have a solid dot, and then I'd use a bracket. Likewise here, if this was a less than or equal to, solid dot and a bracket. So, kind of a quick summary for you. Less than or equal to or greater than or equal to, use solid dot, or if you're using interval notations, then you can use brackets. Less than or greater than, use hollow dot, or if you're talking interval notation, use parentheses.
Problem 78, use parentheses.
Let me look back. 70. I use parentheses for negative infinity and infinity. Infinity and negative infinity always get parentheses. But when you're looking at the intersection, they overlap at these points, so I would include 5 and 8. So I'd use brackets there. So I think we're good on 78. Is there something else that...
Okay, so the difference though is because it's infinity, it's always...
Yeah, infinity and negative infinity always get parentheses. And I'm not going to, bust you on it. If you accidentally use brackets around infinity or negative infinity, I'm not going to take off a point. But formally speaking, it would be parentheses around infinity and negative infinity. Okay. Yeah. So, good question. Jamie?
The union questions are just basically asking like what on the line is covered when you find the
Exactly.
two, and
So you got to list anything that's covered.
and the other one is just what's in between if they intersect, right?
Right.
But they both
It's where they're both covered. So union is where anything is covered. Intersection is where they're both covered. So it's a nice summary. Rhonda?
Can you clarify the flip of the sign?
You mean like right here when we flip this? Whenever you divide or multiply by a negative number, you have to reverse the direction of the inequality. So in this case, I divided by positive 5, so I didn't have to change things. But here, when I divided by negative 150, I had to change things. It'd be the same if I multiplied by a negative number. In fact, we saw that with problem 56. When I multiplied by negative 4, then I had to reverse the direction of the inequality. So it started out as a greater than, and then it finished up as a less than. Over here, well, I guess I didn't need to do anything there. But going back to this one here, I divided by a positive 5, so the inequality didn't flip. Oh, here, all I did was I rewrote it. I didn't do any extra operations. So this is just a different way to rewrite it. What I like about having the variable on the left is that it tells me which way my graph is going to run. So this arrow points to the right, my graph points to the right. This arrow points to the left, my graph points to the left. So it's kind of a nice symmetry. That's why I flipped that around. This tells me the same thing as this. It says y is bigger than 52 over 5. So I want the bigger numbers, they're going to be to the right. But I just like it that way better. Yes?
So just to clarify, if your y is on your right side instead of your left, the way that your arrow is going to point is the opposite of what the sign shows.
Mm-hmm.
If it's on the left, it's going to be the right way.
Correct. Mm-hmm. All right. Good observations. Thank you. Let's turn to some double inequalities. And that would be stuff like we'll start with problem 58. So I've got negative 4 is less than or equal to negative 2 times x plus 8. which is less than 8. So this is a double inequality. And notice that on the one side I've got a less than or equal to, and the other side is just a less than. My goal here is to solve for x. I want to get x by itself in the middle. So let's think here. There's a couple ways that I can proceed, but let me do something that might be a little bit different than what you would choose. Instead of distributing this negative 2, how about if I just divide by negative 2 to start with? And the reason for that is that it's going to clear things up in the middle a lot quicker. So I'll divide everything by negative 2. But let's be careful. We just had a nice little conversation with Rhonda about something. What do I have to do when I divide like this? Flip the signs. Now let's just watch real carefully. If I didn't flip the signs, I would get 2 is less than or equal to x plus 8 is less than negative 4. And then I can finish by subtracting 8 from both sides. Don't copy this because it's wrong. Negative 6 is less than x is less than negative 12. So basically they'd be saying negative 12 is bigger than negative 6. And I hope you know that's not true. So it's just a reminder that when you divide by a negative, you have to reverse the direction of inequality. If you get something that doesn't make sense, look back and fix it, please. So yeah.
Why would you multiply minus 2 times 8 minus 2 times 8?
Say again?
Why we didn't multiply minus 2 times 8?
You could.
And minus 2?
You could. In fact, if you'd like, I'll go back and solve it by doing it that way. And then we'll see which way you like. So here we'll divide by negative 2. And I get I get 2, reverse the direction of the inequality, is greater than or equal to x plus 8 is greater than negative 4. And then subtract 8 from all 3 parts of the inequality and get negative 6 is greater than or equal to x is greater than negative 12. And at least that makes sense, that negative 6 is bigger than negative 12. So that part looks okay. So by special request, let me go back and solve it a different way. And then we'll graph it and look at the intervals here. So kind of repeating our work here. This time, instead of dividing through by negative 2 to start with, let me distribute that negative 2. I'll get negative 2x minus 16. And that's less than or equal to just 8 over here. I accidentally wrote an 18. Then what would you do? Well, I'd probably get rid of the 16 here. Add 16. All right, so I'll add 16 to all 3 parts of the inequality. So that's going to give me 12 is less than or equal to negative 2x is less than 24. Then what? Divide everything by negative 2. And when we do that, we have to reverse the direction of the inequality. So we get negative 6 is greater than or equal to x is greater than negative 12. So you end up with the same thing. So whichever way you find more comfortable. Let's look at this graphically. I've got 2 points, negative 12 and negative 6. What kind of dots or hollow dots am I going to use when I graph this? Good. Where's the hollow one go? Negative 12 to 6. So there's your inequality. There's your graph. See if you can't write the interval. Carefully choose brackets and parentheses. Jamie?
For these problems, it's basically telling you that the x is really just trying to do what intersects, right?
It's not really, I mean, I guess you could think of it as an intersection. But yeah, you're just looking for what's between these two numbers. So x is between negative 12 and 6. What brackets, parentheses should I use around these? Good. Parentheses, negative 6. Thank you. Yeah, I don't think you need to necessarily think of it as an intersection here, Jamie. You just think of it as, you know, what you're trying to do is solve this inequality, and you end up with x being sandwiched between these two numbers. So
For these kind of questions, like, this is a double inequality, you said, right?
yes,
If you get this kind of question on the exam, you're looking for that last, like, -12.
I'm looking for x to be isolated in the middle. So x has to be by itself here. Let's try problem number 66. Negative 4 is greater than 2/3 x plus 2. Excuse me, minus 2. Rats. Minus 2. Let's start this one again. Negative 4 is greater than 2/3 x minus 2, and that's greater than negative 6. Suggestions on how to start this one, or what you would do. All right, get rid of the fraction. How can we do that? Everything gets multiplied by 3. Now that it includes all these terms that don't even have a fraction as part of them. So everything gets multiplied by 3. So that would be 3 times this, 3 times this times 3, and this times 3. See if you can't figure out what that's equal to. Yes. Yes, you do. Well, actually, here, if it helps you, you can think of this as being 3 over 1, because there's not going to be any cancellation with the 2, but the 3's cancel. Those cancel. And it leaves me with 2x. Yeah, you can think of it as 6 over 3, and 6 over 3 simplifies to 2. So negative 12 is greater than 2x minus 6 is greater than negative 18. Then what? Add 6 to all 3 parts of the inequality. Now, one thing that happens a lot of times when I see students work is that what'll start out as a double inequality somehow ends up as a single inequality. That is, one of them just disappears. I don't know why, but it happens. If it starts out as a double inequality, it's going to finish as a double inequality. When I do this, when I finish it up, I get negative 6 is greater than 2x is greater than negative 12. Almost done. Divide by 2. So if I divide by 2, I get negative 3 is greater than x is greater than negative 6. I can graph that. It's going to be hollow dots. Is the interval notation going to have brackets or parentheses? Parentheses. One thing about the interval notation, make sure that it's always lowest to highest, left to right. I'd get a little uncomfortable if you wrote negative 3 to negative 6. That's the wrong order. It's left to right. So, how are you looking on problem 66? Yes?
For this one, you know, like, she was pointing out the inequality sign points the way
Well, that's if the variable is on the left-hand side of things. So it doesn't work so good for a double inequality. You could, if you wanted to, flip this. You could write that equivalently as -6 is less than x is less than -3. And that's a better match to what we have here, that x is between these two. But it's still saying the same thing here. It's up to you. It's up to you which way you want to write it. This way seems a little bit more natural because the smaller numbers on the left, the bigger numbers on the right. You don't have to switch it. But that rule about it points in the direction of inequality pretty much works really the best when you have just a single inequality, not a double. Yes?
So for the double inequalities, you're always going to work from the inside out?
Yes, you want to get the variable by itself in the middle. Okay? I do. We'll pass those out when we need them. Anything else on this one? For homework. Now theoretically, some of this was already done, but for homework, try problems 11, 17 through 21, 25, let's see, 25 through 31, 39 through 59, 65 through 71, and you can skip problem number 43. These are always just the odds. Yeah, thank you. So I think that's a total of about 24 problems out of 100 possible in the book. So that's not too bad. 24% of what's there.